Hello, my mathematicians. This is Miss Foster with Math in Focus, third grade, chapter 14, lesson 3, comparing fractions, part 2 of 3. So we could call this video the 2/3 video. Just had so many different ways to compare fractions. Have to do a lot of videos for it. So yesterday we talked about using your models, drawing bar models, thinking about number lines, drawing any fraction models at all, and then really realizing that since the denominator tells us the kinds of pieces or the size of the pieces that you are dealing with, if all the pieces are the same size, then we just have to look at the numerators and easy peasy. But now, what if we are comparing fractions with equal numerators, where the number on top is the same? In that case, only the denominator or the size of the pieces matter. And this is where we get into remembering the inverse relationship of denominators. The greater the denominator, the smaller the pieces. Now, this can be kind of really freaky to try to understand. And a lot of kids kind of get lost with this and they're like, this 1/7 over here, 7 is more than 3. That's where, my friends, you need to channel your inner greed. Think of something that you love so much that you'd be willing to fight for it. Like, let's say brownies. If you had to split the brownie with 2 friends, or split it with 7 friends, which one would give you the most brownie? Well, when I think about it that way, I only want to share it with 3 of us because then I'm going to get this big piece here. Whereas 7ths are a lot smaller. If I have to share it among 7 people, oh my goodness, we'll just get a teeny tiny part. So that always helps me make it clear, and I invite you to think the same. So if the unlike fractions have the same numerator, they have the same number of pieces, which has bigger pieces. And you can see here that we have 3/5 versus 3/6. Now, they're very close in size, aren't they? But it's more for each piece if we only divide it into 5. And that means if I get 3/5, 3 of those pieces, that'll be more than having 3/6. So the one with a greater denominator is the smaller fraction. It's that inverse relationship that can trip people up. Now, I already did lots of talking about it, but you can clearly see here that 1/3 is greater than 1/7. We can think of the sense of that, or if you need to, just like they did here, drawing it out, always a good idea. The more you draw it out, the faster your brain will get to thinking, wait a minute, I know the smaller the size of the denominator, the bigger the piece. You'll get there, just keep drawing. So let's take a look at these down here. Here we have 2 fractions, 2/10 and 2/7. They have the same numerator, but a different denominator. So will it be that 2/10 is greater, or 2/7 is greater? And I'm just not even looking at the picture right now, la 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 la. I'm just thinking, oh my goodness, if I had to share it with 10 people, teeny pieces, between 7 people, bigger pieces, I'm going with that 2/7 is the greater one. And they chose to say, well, 2/10 is less than 2/7. But that is equal to the expression that 2/7 is greater than 2/10. There we go. So here we're comparing some more unlike fractions. And our friend here, let me get out of her way, says that in her classroom, she has pi A and pi B, and they're vegetarian pies of the same size. By the way, I love British Bake Off show, the Great British Baking Show. If you've not watched it, I totally recommend it to everyone. In England, they have this tradition of making these savory pies, and then you would have a slice of pie for dinner, sort of like a quiche. So that's what you've got going on here. Yum. Mrs. Jones cut 3/4 of pie A for Sue. Whoa, Sue got all this. Amazing. She cut 7/8 of pie B for Tim. Whoa, that's a lot of pie, Tim. Who got the larger piece and who got the smaller one? Now, in this case, 3 and 7 aren't the same, and 4 and 8 aren't the same. So now I need to think about all that work we did in lessons 2 and 3 about equivalent fractions. Is there a relationship between the numerators and denominators of 3/4 and 7/8? Now, a lot of you are going to say, oh, 4 is half of 8, so we can divide 8 by 2. Except, can you divide 7 by 2? Not evenly, and we certainly don't want to be dealing with fractions of fractions. So I recommend that we make this one have more pieces, make it less simple, by multiplying by 1 in the form of 2 times 2. And I'm just going to leap all of this over 7/8 just like they're doing. There's a lot of this action, it seems, with fractions. So let's see. 4 times 2 is 8. That would get me to eighths. And that would be like coming over here and cutting every single piece into 2 parts. But it would be completely perfectly even because you would not be drawing it with a mouse. And then I can see there that I've cut all the pieces, all those fourths into halves. Well, half of 4 is eighths. Fourths are eighths. And oh my goodness, didn't those numbers just get all twisted for you like they did for me? In any case, you can see that 1, 2, 3, 4, 5, 6. You can see that we've got to multiply 3 times 2 to get 6 pieces. And as soon as we do there, we know for sure that 7/8 is greater than 6/8 because we got the size of the pieces the same. Go us! Well done, you! Alrighty. Now, they finished talking about down here, and I thought, well, maybe we could have a nice practice right over here with 1/2 or 4/10. The denominators are different, the numerators are different. 10 divided by 2 is 5, and I can divide 4 by 2, but that still won't give me a common denominator. So let's do it the opposite way. Let's make 1/2 less simple using equivalent fractions. Here you can see that they're multiplying it by 5/5. We've got the same amount of stuff. It's just in different size pieces now. 1 times 5 is 5, and 2 times 5 is 10. Because if we cut every single of those halves into 5 pieces, we'll be dealing with tenths. And then all the numerator pieces will change too. And as soon as I do that, I can absolutely see that 1/2 is greater than 4/10 right over there. And again, if I was using those fun signs, I would have used that one right there. So that leads us, we've been trying to go right ahead and to use those equivalent fraction skills. We couldn't use division last time, but sometimes you will be able to. And if you do, my friends, we have discovered that when we're learning fractions, it's way easier to work with bigger size pieces. That's why we simplify things. And again, the magic of math, we're uncutting stuff. You just can't uncut stuff in real life most of the time. So which is less, 3/12 or 2/4? Well, I'm noticing that 12 and 4 share, 4 is a factor of 12 and 12 is a multiple of 4. So and also 12 divided by 3 equals 4 and 3 is a common factor of 3. So let's divide them by 3/3. 3 divided by 3 is 1, 12 divided by 3 is 4. We get down to 1/4. Now I can see that my numerators are the same. And so 3/12 is less than 2/4. Let's try it over here. We've got 8/12 or 1/3. Which would you rather have? Well, 8 and 12 share some common factors. They share the common factor of 2, but they also share a common factor of 4. That means I can divide both 8 and 12 by 4. So the bigger the factor you divide by, the quicker it's going to go. So that's why we are going to be looking in 4th grade for the greatest common factor. The greatest common factor between 8 and 12 is 4. They do share 1 and they do share 2. But we'll use 4 because it's the biggest one. And we're comparing things, aren't we? So 8 divided by 4 is 2, and 12 divided by 4 is 3. And all of a sudden, it is crystal clear. We have the same denominator, so we know that 8/12 is greater than 1/3 because 2/3 is greater than 1/3. And there we are. So my friends, using those equivalent fractions, really digging into what does the denominator mean? It's the number of stuff that you get, number of pieces you get. What does the denominator mean? It means the number of things in a whole, whatever it is, but it also tells you about the size of the pieces or the kinds of pieces. Thirds are different than 12ths. And so we can really leverage that information to compare fractions. Hey, thanks for playing Comparing Fractions with me, you guys. There are yet more ways. This is crazy, but I'm going to put them in another video. And so, bye-bye for now.